Hello everyone, welcome to Virtio for Zen on ARM Talk. My name is Vikram and I work as a software engineer at AMD. In this talk, we will briefly discuss about what is a Virtio and how to use it for Xen Hypervisor on ARM architecture. And we'll also talk about using the QEMU as a backend for Virtio. Virtio is a very known topic to all of us. It's basically a IO isolation technique which implements a communication framework for IO interaction between the guest domain and hypervisor. Essentially, it provides a lightweight interface which allows the guest domain to access or utilize the physical devices or emulated devices on hardware domain side. So what happens in virtualized environments, the guest domains need to interact with various devices like a network adapter, storage device, graphic cards, or input-output devices. And Virtio simplifies this process by providing a set of common standard drivers and device backend implementation. Let's talk about a few more key features of the Virtio. As we talked earlier, Virtio supports a wide range of virtual devices, including like Virtio Net for network and block devices, console devices, and SCSI devices, and even GPU devices like Virtio GPU. Virtio is designed to be platform and hypervisor independent, which makes it very compatible with popular virtualization platforms like Xen, KVM, VMware, and Hyper-V. And lastly, Virtio is supported across many common operating systems like Linux, Android, Windows, and QNX. And there are a lot of Virtio drivers available across these operating systems. Let's briefly understand the architecture of Virtio. So this diagram just provides a very high level overview of the communication flow in Virtio. We can break it into three parts: front end, transport layer, and backend. So front end is basically the guest domain where the Virtio device driver locates. This is just a software component inside the guest domain operating system, and it's responsible for providing a standardized interface for communication with the Virtio devices. Virtio device driver relies on virtual queues to send and receive the data. And like standard kernel drivers, Virtio driver accepts input-output requests from user applications and transfer those IO requests to the backend Virtio device on hypervisor side. Let's talk about the middle layer, which is transport. So what happens here is that it uses virtual queues, which are a shared ring buffers between the front end and Virtio backend. The purpose of using these shared buffer is to efficiently transfer the data and also to reduce the memory footprint and improve performance. And these buffers are usually part of the memory of the guest operating system on guest domain. And last is Virtio backend. Virtio backend basically translate the requests it get from guest domain, and it translates those to an actual operations for either physical device or emulated device. And it also responsible for managing the device emulation, data transfer, and also manages the virtual queues. Next, let's talk about Virtio for Xen on ARM, as there has been a lot of interest for Virtio on Xen to provide a standardized interface and device models for paravirtualized environments. And there were also a few talks on Virtio on Xen in previous years, Zen Summit and other open source conferences. So for Zen ARM, front end side is pretty stable and developed. Front end can notify the back end using memory writes, and those writes are forwarded using IOREQs. So IOREQs are basically a connecting link between the device emulator, which is backend, and the guest domain. For front end, which is guest domain, all the required guest device tree updates for Virtio are already present in the Zen tree. And Zen also has the support for privilege for end mapping, which is to allow the mapping of the guest memory in an address space where backend can also access it. So what about backend now? One of the main problem for Virtio on ARM is the absence of ready-to-use Virtio backends. There are not really many open source available backends, and that's where QEMU comes in the picture. QEMU already has support for a whole lot of different Virtio devices like Virtio Net, Virtio Block, Virtio Serial, Virtio IO MEM, Virtio GPU Clock, CAN, and others. And it has all the required infrastructure for even adding the new Virtio devices. QEMU is open source, and QEMU has Virtio base model as a QOM, which is QEMU object model, and which makes it very easy to use it or extend it for new Virtio devices. So now, given that QEMU has a lot of Virtio devices emulated, next thing is that can we use it for Zen on ARM? So first thing which we did in last year's Zen Summit was to introduce a new minimized, very minimal QEMU ARM machine, which is compatible with Zen, and it was named as Zen PVH. And now we have added Virtio support on this machine. So let's talk a little bit more about what is this new machine does and how it works. So the Zen PVH machine for ARM in QEMU. So now, like, we are successfully able to upstream this Zen PVH ARM machine, and it's available in QEMU 8.1. Basically, to make it work for ARM architecture, we had to basically move a lot of common code to hardwares and directory and make it accessible for both the ARM and x86, and that arc neutral code contains IOREQ server parts also. So what this machine does is that it creates an IOREQ server and registers it with this, and it also has support for TPM emulation, and which can be used to provide each guest with its own TPM. And now we have added the support for Virtio Net and Virtio Block in this device. And the device can be used like very standard way in the QEMUs with just mentioning the machine name as NPVH. As I said earlier, it's available in 8.1 version, and here's a link for those who are interested. Okay, next, Virtio for Zen on ARM with QEMU as backend. So in order to use Virtio backends, we need to allocate Virtio memory parameters like base address and IRQs, and also register the corresponding Virtio buses in this Zen PVH machine. It can support up to 10 devices, and this was done to keep it in sync with the Zen Toolstack, which allowed maximum of 10 Virtio devices. And most of the constraints we have used for Virtio are taken from the Zen Toolstack public header, which is arm.h, just to keep it aligned with the toolstack. And lastly, we have added the -m option for the RAM size, and this was done to support the Virtio backends, as then mapcache.c maps the guest memory using foreign mappings. And this -m option for the RAM size is also useful for Zen Commons script, which is used to start and stop Zen Store D and Zen Console D. And it uses QEMU to do that. And in this Zen PVH machine, if we run it without -m option, then machine can just start a QEMU, but without any TPM or Virtio support. And that's what the Zen Commons script only needs. So it can act as a QEMU backend for the Zen Commons script also. And RAMs are basically mapped from guest RAM 0 base address. Again, this is taken from Zen Toolstack. And if there is extra amount of RAM to be allocated, which cannot fit in the RAM 0 size, then it will be allocated to the RAM 1 base onwards. Okay, next let's see what changes we had to make in the tool stack to make Virtio MMIOs and Virtio network. So for the Zen tool stack, there were not many changes as Virtio MMIO and net were all already present in the Zen tools, and Zen had the support to create the required Virtio device tree nodes for the guest. We just had to change the order in which the device tree nodes are created to incorporate the QEMU support, because QEMU maps the Virtio MMI devices in the top to bottom order, which means the Virtio 0, which is like first device, is mapped at the highest Virtio base address. And for Virtio net to use with QEMU for PV domains, we just added the extra option for type IOEMU, and we enabled it for the PV domains. And with that option, as you can see the commands below, so it generates these commands, and these are for the QEMU DM. And it needs a bridge to basically connect the virtual network to the actual physical network interface, which is located in domU. So for that, we are using the PRCTL tool to basically create a bridge between the physical network interface so that the virtual network in the guest domain can connect to it and access the network. Next, so here are the different commands and build configurations. For QEMU, you just like build the QEMU 8.1 with enable Zen, and when you build, please build it with the Zen libraries 4.16 onwards. And for the Zen, in the Zen configuration, just enable the IOREQ server support and config expert options. For Linux, just need to enable the Zen Virtio option. And for domU, because right now the QEMU runs in domU here, so which means our backend always lies in domU. So we had to create a bridge there if we want to use the Virtio net. If we don't want to use Virtio net, there's no need to do this. Okay, next, now we see the commands to create the guest domain. And here we have added options to create the domain with Virtio disk and Virtio net options. For the Virtio net, we just added type equal to IOEMU, and for Virtio disk, we just added specification equal to Virtio. And then we create the guest in usual way. And once the guest start booting up, you can also see the device drivers getting propped for Virtio block and Virtio net, and you can also see the sys class net and sys class block to see the status of the network and disk drivers. So disks are basically propped at like Virtio block backend and Virtio block. Each of them appears as a separate disk inside the guest, and you see here for the mapping also, because this is connected to Virtio 0, and this has the higher base address versus Virtio 1 has the lower address. So this is just to keep in sync with QEMU because things map from top to bottom, as you had talked earlier. Next, let's see the issues with Virtio with the backend. So one of the main concern with Virtio with backend is that backend can access the guest memory, which is not good from security point of view, but because backend has the privilege over the guest to perform the foreign mapping, so it can still access the guest memory. Solution to avoid this was to improve the isolation by sharing the memory using grant tables in Zen, and this was done by Jürgen and Alexander in 2022. So what they did was that they introduced a new Virtio transport device driver for the guest kernel, which translated the guest physical addresses into grant references. And this basically enabled Virtio data path communication over a mutually negotiated shared memory region between the guest driver and the device backend. Now, this improved the isolation as backend doesn't need privilege over the guest anymore. Status of this work for the Linux, the patches are already there in the upstream, and I would suggest to check the presentation if you want to learn more about the work. For QEMU, mapping is done dynamically, so it adds in Zen.grant a pseudo-RAM region, and that patches are pretty much like independent of x86 or ARM, but the initial work by Jürgen was done for the x86. So we have added support for this in Zen PVH Machine, but it has a dependency on Jürgen's patches for mapping the Zen grants in QEMU. Let's see the commands for using Virtio with grants. Building the QEMU is same. Building the Zen is same. For Linux, we just need to enable the grants for Virtio. So there's a config option for that. And for the new domain creation, everything looks same. It's just we updated the Toolstack with an option to enable the grant. And if you see the commands here, the only extra thing it appends for the QEMU DM was it says the for MIU it sets the forced legacy option as false because QEMU has two sets of Virtio implementations, so the latest one only supports the Virtio with grant. Rest of the commands and everything looks same. And Virtio grant on ARM with QEMU. So status for this is the Zen PVH machine for ARM. We have the working solution, but we are yet to upstream the patches. And given that this might take a few months because it also has a dependency on a few of the Jürgen's patches which are not upstream yet. For the Zen side, we have added a QEMU DM creation option to incorporate the grants option for Zen Toolstack, and that creates a forced legacy option equal to false for QEMU DM. We need to upstream this with the Zen. And we also added the IO MMU node and connected them with the Virtio MMIO. And added Excel config for generic Virtio and Virtio with grants. And we are yet to upstream the patches to the Zen community. So to summarize, we have introduced a new QEMU machine for Zen on ARM, and this provides fully emulated Virtio backends for Virtio MIO, Virtio Net, and TPM. And this QEMU Zen PVH machine communicates with Zen via IOREQ, and this is mainly available in domU as of now. This can support up to 10 devices, and it's very easy to expand or add different Virtio devices to this QEMU, as QEMU in general already has support for those Virtio devices, and adding them to this as an PVS machine will not be too much of extra work. And lastly, for Zen Toolstack, we have added a force legacy equal to false option when QEMU DM is created, so that QEMU can run on the latest transport protocol for Virtio with grant support. Let's talk about the future work. We have cleaned up the patches for generic Virtio support on this machine, and we plan to send the patches by next month. We also need to bring in the support for Virtio GPU and Virtio PCI, and we need to create the configuration to run this QEMUs and PVS machine in other domain like domD instead of dom0. And another configuration or another test case that we are yet to do is that because this machine as of now it's in dom0, so right now using it with dom0 less setup will not work. So we have to find some kind of way to make it work with the dom0 less setup, like either some kind of notification using Zen store, so that the Virtio driver in guest domain where still dom0 brings up QEMU and then drives to some shared Zen store path, and guest driver is then propped. Or another alternate would be make the Virtios hot pluggable, but not sure if this is supported on ARM and QEMU on ARM, and how much work will be involved in this. This is something we're going to look into in next few months. For Virtio grant support for this machine, the patches has dependency on Jorgen's patches, and we'll be speaking to him to see if we can try to upstream the QEMU patches for grants. And lastly, make config options simpler. This is something for the Zen tools. Stefano was like, if we can add like different configs for Virtio generic and Virtio grants to keep things very separate. So that would be something we'll be adding in next few months. That's all I have. Thank you so much for listening.
Vikram, are you online? If you are, feel free to answer. Okay. If you're not, I'll try to answer instead. So the question is, what's the performance impact of Virtio with grants compared to normal Virtio? So it was surprisingly small. Now, we have not, Vikram, as far as I know, has not done measurements. So our team at AMD has not done measurements yet, because we are just build this infrastructure still. But Jürgen last year, or was it Alexander from EPAM? Yeah, they ran the benchmarks, and it was within 5%. So I don't remember exactly the difference, but it was small. Keep in mind that also the default Virtio implementation is not that fast without EPAM's improvements that are not upstream. Right? Which are so right now, let's say the privileged Virtio implementation still map things on demand rather than everything at once beforehand, And EPAM made a pass to maps everything at once beforehand, but there are obvious concerns because it will make the solution even less secure than it already is, which is not very secure. So it's debatable whether one will want to decrease further I think, the security of the solution. But that is faster. Yeah.
Don't you have map cache on ARM?
We have introduced the map cache on ARM.
So make things probably faster as long as the guest tends to use more or less the same addresses.
Yes, so that basically right now it works exactly the same between ARM and x86, the QEMU stuff. There is no much of a difference, yeah, for better or for worse.
And there's no B cost or anything like that?
No, I don't think so, no, yeah.
So I have two questions. First question is, why do we limit ourselves to 10 on why not leaving the two stacks telling QEMU this is the device and this is where they are? Because in the way you're doing it, you rely on Zen to be compiled with QEMU, and ideally you want to build one binary of QEMU and you don't have to care about the version of Zen.
So, yeah, that's...
It's the same with the RAM, is that you're putting yourself in your QEMU and then tied together on very tags together.
So I'm trying to remember the details. This is a question that Vikram would have been able to answer better than me. Okay, so I'll try to remember. So I think the limitation of 10 is due to either I don't remember if it's due to the allocation of the bus, the number of slots you allocate in QEMU by default in Virtio MMIO, or if it's because of the size of the allocated space for Virtio. You keep in mind, just to finish what I remember, in Zen we have a pretty large space for Virtio, right? But it doesn't mean that in QEMU we have allocated the same space for Virtio. So in QEMU you need to pick basically same as we do with Zen. You need to pick a range, right? And a number of interrupts, and I think we picked 10.
I totally agree with that. The main thing is that what's been said is that it's been compiled in QEMU, whereas what should have been done is passed on QEMU command line, same from the memory. I think it's a shortcoming that will bite us quite quickly.
Okay, yeah, that makes sense.
The second question is, what's your plan to integrate QEMU in Zen? Because today we're using QEMU x86.
No, not anymore.
Yeah.
Not anymore. So the Xen PVH machine, so the Xen PVH machine is not x86 any longer.
It's not in Zen. So today, if I build Zen, I would still
yes. Oh, okay, I see what you're saying. Yes, you're right. So at the moment, we don't have a plan for that. No, that is not a good idea. Okay, we don't have a plan for that because our build is done through Yocto, and Yocto builds QEMU outside of the Xen build. So we don't go through the, it's not, at least in our version or our configuration of meta virtualization, we don't build QEMU through the Xen build of QEMU. So we build QEMU separately using the Yocto QEMU build. So we don't need that integration. Obviously, I think it's a good idea to have it. I was just saying it was not on our radar at the moment.
Currently, it's not only limited to the build, it's our tools and etc. are taking into account that they start the x86 version. So you need to change something for that, but we had the issue with Yocto and we managed to make Yocto build whatever we want for QEMU, which is only suitable for Xen and not the big fat QEMU version with all architecture, which is consuming you 500 gigs, 500 megs of disk. That we can help on. Okay.
Does it actually matter which architecture, which QEMU binary you use? Can't you compile a Xen PVH can't you use a Xen PVH in the one you already use?
Yes and no, in the sense that no, it does not matter. So you can, up until now, up until this work from Vikram, we were, if you wanted to use anything, we have previous experimental versions that were using QEMU system i386, right, on ARM. The problem is you wouldn't believe how much confusion that generates, because everyone on ARM, all the customers look at it and they get scared. Are you doing x86 simulation now? Are you doing translation of x86 instructions? So I think it's worth doing just to avoid those questions from the customers alone.
What you want is like the QEMU PVH. I think like the way you're building it at the moment is that it's focused to ARM. We will not be able to get the same code base working on ARM on QEMU, on ARM on x86 in the way you do it. Because you're relying on SPI and things like that, whereas you could have abstract a little bit more on command from then. There would have been no difference. Whereas now you need, I need to remember, is QEMU R64 for ARM on QEMU system.
So that's another good question that is in the detail of the QEMU integration, and Vikram would have been in a better position than me to answer. So I don't have all the details. But you're right. The Xen PVH machine has some dependency right now, like the SPI and so on. But it was written to be easily portable to actually PVH. Right. So also, I mean, right now we build it for QEMU system AR64. It's made so that we can also use it in QEMU system x86 or i386. It's not going to work today, so you're right, but it's still made to be possible. So I don't expect it to be a big work to enable that. And we're going to look into that because we're going to need it for the x86 PVH architecture. So we'll look into it.
I have two more questions. What's the plan to security support IOREQ for ARM?
So I don't have a plan at the moment. But maybe we can simplify the question. What's the plan of moving IOREQ out of experimental? So I think that would be a good idea. I think we should.
You can't.
Because there are problems.
There are problems, yes.
Okay, let's discuss them and we'll take them. We'll add them to our to-do list.
I think on Virtio, we need to have a general question on how do we design the transport so that we don't hit ourselves because we go too far using something that will have security issues. That's the current status we have. In the long term, we'll have safety issues for the same kind of reasons and security. And the general question on IOREQ grants, we had discussions 2 years ago, I think, at the Xen Summit on the Argo solution. We need to have a general thinking on that because it will be hard to find a solution that is suitable for all use cases. But right now, the security issue is concerning. And if we look at what you presented yesterday on safety, where you say, okay, I don't care, my DOM0 is completely independent in the backend to the front end, so I can have a front end with safety and a back end which is not safety compliant. This is not possible right now. DOM0 was untrusted.
The back end non-safety and the front end safety.
Yeah, but in this case, you need to make sure you have a complete independence so that the backend cannot attack the front end or cannot impact the front end. We need to be careful when we design that because the current solution with IOREQ is better with grant table, but we still have a lot of issues there that we need to analyze.
That's definitely true. So the grant table solves a major blocker, the first major blocker, which is the backend is privileged. But is it sufficient? It's probably not sufficient. And also depends, as you know, on the level of on level of safety, level of ASIL, and the way the front end is written. I mean, my gut feeling is it might be possible to write a front end that is already, just with Virtio with grants that is maybe safe. Would it be possible to write a backend that is safe? I don't know, because of the ring indexes, right? So the ring indexes will need to be, read only in one direction and write only in the other direction, and the Virtio rings today is not like that. So that's another issue that affects Virtio. The analysis is not simple, right? So there is a complex set of things that you need to look into to see if it can actually be safe. Yeah.
I think one of the issues in that is typically the map cache where you say, okay, I will keep some pages.
Virtio Grants doesn't use the map cache. The map cache is only for the privileged version.
So when you're using grant table, you use map cache that so you unmap directly whatever was given by the guest when you don't need it anymore.
That's right.
So
when you write the response, I guess.
Yes.
That's going to be
That's the
fast.
same as
That's
PVH.
that's what is going to be slow. The interest of map cache is definitely that you keep the pages mapped.
But you cannot do that with grants because the front end will try to unmap. Well, will try to revoke the grant when he gets the response.
Well, I think you need a protocol.
So you need to have
Yeah.
it mapped before.
We need something where we find a in middle solution so that you can handle those kind.
Grants.
Mm.
But that's not super nice.
Yeah.
There is a work from, Leonardo has looked into it. Do you want to talk about it, Bill, or?
Well, there's a couple of things. So we're trying to do VirtIO between cores that potentially have a hypervisor and cores that don't. So there's no common hypervisor underneath. And VirtIO MMIO has several blocking issues with that, the same issues that cause you to rely on IOREQ. So we're hoping that we can make a modified VirtIO MMIO that you negotiate something and say, okay, I don't rely on emulator magic, hypervisor magic to make this go to the other side. I'm gonna, do a doorbell, know that the response has happened on the other side, and do that. So that's the IOREQ issue. The other thing that in this, you got Cortex A's on this side and M's or R's on this side, is they often have only a common a small shared memory aperture. So we're focused on I2C and SPI and some of these that aren't super high performance, so a memory copy isn't a big deal. So we're working on that problem. I mean, you can force fit that into disk and other network and things. Network's a little more interesting because you could potentially allocate your driver could arrange to allocate the buffers where they need to be, at least for receive. But anyway, there's a number of things there. I think the most interesting intersection, I was assuming Zen wouldn't use what we're doing until you configured Zen down to the point where it doesn't do grants and things like that. And then you have a tiny hypervisor. The smaller, the simpler the hypervisor, the more it looks like the AMP configuration. So that's kind of why I'm listening to all this stuff. I had a question. How hard would it be to take what's working today and make it work for a DOM-D instead of a DOM-0?
I think Vikram is working on that right now. Okay. Right, so it should not be difficult. It's one. So you see, the reason why we're doing the Virtio with grants work is so that the Virtio backend is not privileged. Now that is definitely a key requirement. But not sufficient for safety, like Bertrand was saying. But definitely without that, there is not even worth discussing. Okay. Now, the best way to validate that everything we're doing actually works is to move QEMU out of DOM0. Not necessarily because we want it out of DOM0, but because if it's out of DOM0, it cannot be privileged. So it's like the test. Did we do this for something or is for nothing, right? So Vikram is, as we speak this week, was working on moving QEMU to DOM-D to check that everything works. Exactly, not because particularly we're interested in DOM-D right now, but as a verification of the work.
Yeah, just one thing. If you probably want to have the front end safety certified, you need to have a bounce buffer in order to avoid leaking data to the backend, because usually we grant map 4K, but there's a lot of other data in that page that's not supposed to be seen by the backend, so you will need a bounce buffer.
Not necessarily a bounce buffer.
Well, not about data. You're mixing safety and security. Safety does not care about data leaking, usually not. No, what you care is for anybody to impact whatever is running in the safety context. So
can I interrupt? So we want to do a group photo before everyone leaves. Are you guys at a state where we can go into the other room now, or do you want 5 minutes, or what?
But data leaking is not really a concern for safety. It's more the fact that as long as the other side has ways to control what is accessed, that's okay. It should not impact your safety code, or it should not flood you with interrupts.
Those VMs are provided by you.